if I told you I could type on a keyboard right here and instantly control a high-definition workstation sitting over 6 miles away with zero lag, you probably think I was, like, tapping into some classified military satellite.
Yeah, that definitely sounds like science fiction.
Right. But today, our deep dive takes us into a surprisingly terrestrial piece of hardware. We are looking at the spec sheet for the SmartAVI FDX-3000-PRO-TX-S.
Which really does sound like a piece of a spaceship.
It totally does. But it's actually a single-mode fiber extender. And the mission today is to explore the extreme physics required to make it pull off that exact trick for you.
It's an incredible piece of engineering, honestly. We're talking about sending a flawless 1080p, 60 Hz video signal, plus stereo audio, and RS-232 serial data for industrial controls.
And USB inputs too, right?
Exactly. All of that across 10 kilometers, which is about 6.2 miles, without a single glitch or dropped frame.
Okay, let's unpack this. Anyone who's dealt with, enterprise AV setups knows that standard copper cables.
Oh yeah, they fail fast.
Right, your off-the-shelf HDMIs or USBs, they're going to tap out at around 20 feet.
Yeah, the electrical resistance and capacitance just distort the signal entirely.
It's like trying to shoot water through a tiny, short garden hose that just loses pressure immediately. Or, well, trying to shout complex instructions down a long, winding tunnel.
Yeah, eventually the echoes garble the words completely.
So how exactly is this device cheating that physical limit?
Well, what's fascinating here is the complete shift from electrical transmission to optical transmission, specifically using single-mode fiber.
Single mode being the key word there.
That term is the key, yeah, because multi-mode fiber generally uses LEDs to bounce light off the inner walls of the cable, which is fine for, shorter runs within a single building.
Right, but not 6 miles.
No, definitely not. Single mode uses a highly focused, precise laser shot straight down an infinitesimally small glass core.
Like, perfectly aiming a laser pointer down a tube so it never actually hits the sides.
Exactly. Because the light isn't bouncing around and dispersing, the signal maintains its total integrity over massive distances.
Oh, wow.
Yeah, it translates all that heavy data, so the uncompressed video, the continuous keyboard, strokes into pulses of light and just fires them across a sprawling campus instantly.
That optical engineering is undeniably impressive, but honestly, I'm kind of stuck on the $1,699.15 price tag for this compact little chassis.
It is a very specific, hefty number, yeah.
Right. And we live in a world saturated with enterprise-grade, heavily encrypted Wi-Fi networks. Running physical glass strands through walls and underground feels almost archaic.
I mean, I get why it seems that way on the surface.
Why go backward to hardwiring just to get a signal across a facility?
Well, if we connect this to the bigger picture, it really comes down to absolute physics-based security. The spec sheet specifically highlights that this operates without the risk of interference or interception.
But Wi-Fi is encrypted now. How is this fundamentally any different?
It's about the nature of the medium itself. Anytime you push data through copper wires or broadcast it wirelessly, you are generating an electromagnetic field.
Okay, sure.
And that field can be passively sniffed by hackers sitting outside the room, assuming they have the right equipment. They don't even have to touch your network physically to intercept the raw data.
So copper and wireless inherently broadcast their presence, whether you want them to or not.
Precisely. But fiber optics use light that is completely trapped inside glass. It emits absolutely zero electromagnetic signature.
Wait, really, zero?
Zero. To intercept that data, a bad actor would literally have to dig up the cable, splice the microscopic glass fiber, and bleed off the light.
Which I imagine would be noticed pretty fast.
Instantly. It would drop the connection and trip the system's alarms. So passive interception isn't just difficult, it is physically impossible.
So what does this all mean for you? It means this durable little box isn't just an over-engineered extension cord for your monitor.
Definitely not.
It's replacing a vulnerable broadcast with an impenetrable, physics-defying beam of light, quietly doing the heavy lifting of keeping high-grade data secure day in and day out.
Right. It guarantees the absolute integrity and privacy of your most sensitive inputs and outputs, completely regardless of the distance.
Which leaves you with something wild to think about.
Yeah.
We rely on these physical beams of light for total security right now, but researchers are already looking at how to apply quantum cryptography to these exact fiber links.
Oh, that is just a whole other level.
It really is. Soon, the data traveling through these glass tubes won't just alert you if someone tries to physically splice the cable. The very act of a hacker trying to observe the light particles will instantly scramble the data into useless noise.
That is
It
mind-blowing.
is. Next time you see a perfectly clear monitor in a massive secure facility, just think about that invisible physical light speed infrastructure running for miles right beneath your feet to make it happen.